All right, team, I'm going to do the miscellaneous derivative model. First thing I'm going to do is write my name on it. I'm also going to remind myself of the goal. Remember, if I can get 4 out of 9 points, that would give me a 3 on the AP test. A 5 out of 9 would be a 4. And hey, if I can just get 6 out of 9 points, that's a 5. So I might be prioritizing what are the 3, 4, or 5 points I'm going to get on this question. All right, part A is talking about a train. It's moving with a velocity v of t, and it wants to know the acceleration when t equals 3. It also says, hey, include units. So I'll talk about that in a second. Units. Okay. First thing I'm going to do, I don't like square roots. There is a rule for the derivative of square roots. I think it's confusing. I think it's easier to write this as 36 minus t squared to the power of 1/2. Now, in order to do this, I'm going to do the power rule. As a power rule example, let's say I had y equals x to the 5th. What I would do is I would bring down the exponent, so y prime would be 5x to the power of 4. And I'm getting that by doing 5 minus 1. So you bring down the exponent, subtract 1 from the current exponent. So I'll do v of t is equal to, I'm going to bring down the exponent, so that's 1/2. 36 minus t squared. Close the parentheses. Now, I always think of this as 1/2 minus 2 over 2. 2 over 2 is, of course, 1, so I get a negative 1/2 to the exponent. Now, this is also a chain rule problem. I'm going to do a quick chain rule example. I'm going to use y equals tangent of x to the 5th power. Oops, close my parentheses. Now, to do the derivative, I'm using the same power rule, so this would be 5 tangent of x to the 4th. But for the chain rule, I need to do the derivative of the inside function. Anytime I see one function inside of another, here tangent is inside the x to the 5th. And the derivative of tangent is secant squared of x. That's the chain rule. If you need practice with that, I linked to Khan Academy, and you can do all the chain rule practice you want. So let's do the chain rule of this part. I have to do the derivative of 36 minus t squared. The derivative of 36 is 0. The derivative of minus t squared is negative 2t. And I'll probably put that in parentheses so that the grader knows it's being multiplied and not subtracted. Oh, I'm sorry, this is v prime of t. Thank you to whoever caught that. Now, this problem, v prime of t, of course, is the same as acceleration. So now I need to do a of 3. I'm going to write it all the way down here, so I have plenty of room. A of 3 is going to be 1/2 36 minus t squared to the negative 1/2 power times negative 2t. So a of 3 would be 1/2 36 minus 3 squared to the negative 1/2 times negative 2 times 3. I'm just substituting in 3. Now, leave it. Don't try to simplify that. If you do, use Desmos. Now, the only thing we need to do are units. Here, the units are velocities in meters per minute. So this would be meters per minute squared. Those are the units. All right, now I'm going to do part B. Part B asks you to find h prime of 6. They're going to say, hey, what's h prime of 6? And they tell you that h of x is equal to f of x times g of x. And anytime I see something multiplied by something else, I know to use the product rule. A real quick product rule is, I always think of this as first derivative second plus second derivative first. That's a weird way to write first, but you guys see. So I've got my first and my second, so I'm going to write h of x is, the first thing is f of x. The derivative of g of x is g prime of x plus g of x times f prime of x. First derivative second, second derivative first. To do h prime of 6, all I'm doing is, hey, f of 6 times g prime of 6 plus g of 6 times f prime of 6, okay? Now, on the exam, you might be given a function, or you might be given one of these tables. I'm just going to read off the table. Oh, f of 6. So when x is 6, f of 6 is 4. So it would be 4. G prime of 6 is -1. Plus g of 6 is 3. F prime of 6 is 5. And make sure you say, oh, hey, this is h prime of 6, so that the grader knows. And just leave it here, because you get 1 point for the answer, and you get 1 point for taking the derivative. So you are totally able to leave it like this. If you really want to write this as 11, you can, but I would recommend just stopping here. In part C, do this on the same paper, because we're going to use the same table. It says, hey, p of x is equal to f of x divided by g of x. Okay, so I'm going to think quotient rule, because we need to find p prime of 1. Quotient rule. Mr. Laughlin, when he was in high school, he memorized this as low derivative of high minus high derivative of low all over low squared. And put this in brackets for me, because you have to square the whole thing. So low derivative high, so p prime of x, low derivative high is g of x times f prime of x, minus, product's a plus, quotient's a minus, high derivative low, so f of x, g prime of x, all over g of x squared. And put that in brackets for me, so that the grader knows you're squaring the whole thing. I don't want the grader to think you're doing this. I could see a grader being like, I don't know if this person knows how to square things. All right, so let's do p prime of 1. I'm going to go back up to my table. Here are all the values I'm going to use in the first row. You probably won't be able to see it, but you can follow along on your Google Doc. So I got g of 1. Oh, sorry, and you get 1 point just for doing the derivative. G of 1, f prime of 1 minus f of 1, g prime of 1, all over g of 1 squared. Looks like I'm going to run out of room, so I'm going to go over here. So p prime of 1 is equal to g of 1, it would be 2 times 3 minus f of 1 would be -6 times 8. Again, I'm just getting the numbers from up here. All over g of 1 is 2, so 2 squared. And again, team, once you get here, leave it, because you get a point. if you make a mistake, like you forget to square 2 or you forget to turn this into a plus, you would then lose the point. Just stop here. All right, let's do part D. Now I know I said these were miscellaneous derivative problems, but this one is an integral. And there's a lot here, team. If you've already gotten 5 points on this FRQ, maybe this is one you skip on the quiz, but I'm going to go through it. So, the integral from 1 to 2 of f double prime of x dx. Now, first thing we have to know is that you go from, if you take the derivative of f of x, you end up with f prime. The derivative of that is f double prime. Now, last January, we learned that you can take the integral of f double prime and end up with f prime. And you can go from f prime to f by also taking an integral. So I'm going to rely on that fact for this one. Now, another tricky part about this. Oh, and did I rewrite this silly thing? Or write it wrong? I totally did. Because it's f double prime of 3x dx. Okay? This means we're going to have to use u substitution. U substitution is for functions inside a function, like if I had to do the integral of sine of, I don't know, x squared dx. I see the inside function, I know I have to use u substitution. This is the integral form of chain rule. So when you're doing derivatives, it's chain rule. When you're doing integrals, it's u substitution. And that's why it shows up in these derivative questions, because I want to make sure you can do chain rule backwards, even though it's hard. So I'm going to make u my 3x. That's because it's the inside function, which means du is 3dx. So I don't have a 3dx. I have a 1dx. So what I'm going to do here, so I have the integral from 1 to 2, f double prime of 3x. What I'm going to do is I'm going to multiply the outside by 1/3, and I'm going to multiply the inside by 3 dx. Okay? Like if I have 5 and I multiply by 1/3, and then I multiply by 3, that's still 5. That's how I can do that. Now I'm going to do my u substitution. So I have the integral. 3x is going to be my u. So f double prime of u 3dx is my du. And this 1/3 still stays out front. 1/3. Okay. Now, the endpoints. These endpoints are in x land. We need to convert them into u land. Now, to do that, we know that 3x is equal to u. So I'll just take 2 and multiply it by 3. That gives me 6. And 1 multiplied by 3 gives me 3. So this becomes the integral from 3 to 6 of f double prime of u du. That's the u substitution. And I think if you can just get to here, this is the first point, doing the u substitution. Now, now we're ready to take the integral. So the integral of f double prime is f prime. So this 1/3 stays out here. 1/3. Not the integral anymore. It's just f prime of u from 3 to 6. They put these at the end because we're going to plug them in here in a second. You don't need a plus c here because we have endpoints. If they did this problem without the endpoints, you would need a plus c. So, and this is the fundamental theorem of calculus. I'm going to do top minus bottom. So it's the integral of f prime, I'm sorry, not the integral. It's just 1/3 multiplied by f prime of 6 minus f prime of 3. I'm going to go back to that chart I had on the last page, but I have since, oh no, here it is. Yeah. So I'm just looking for f prime of 6 is 5. F prime of 3 is -2. So I get 1/3 multiplied by 5 minus, oh no, 7. Good. I almost did it. Caught myself. F prime of 3 is 7. I said it wrong a second ago. And again, just leave it, because here you have the point. If you make a mistake and say, oh, ooh, this all equals -2, I got it right, they will then take this point away. Just being clear. Just leave it, or hey, use Desmos. All right, team, time for part E. Now again, you might already have your 5 or 6 points that you need, and if you get to this on the quiz, maybe this is a skip. But I'm going to show you how to do it. So this is asking for the tangent line at 1, -4 of this equation. So to do a tangent line, I know I need y minus y1 equals mx minus x1. Now, the x and the y aren't really a problem. Get y, that would be +4 equals x minus 1. But the slope is the problem. I don't know the slope of this curve. Good thing, that's what a derivative is for. So I'm going to take the derivative of this guy. The derivative of x squared is 2x. Here I have product rule because it's x times y. So first derivative second is going to be x. The derivative of y is dy dx. Plus the second thing, which is y. And then the derivative of the first is just x. Or no, sorry, is just 1. Just leave it as 1. Plus 2y, and again, the derivative of y is dy dx. You can almost think of this as a chain rule thing. The derivative of 10 is 0. Now, I have to solve for dy dx. At the end of this, I'm going to say, oh, dy over dx equals something, and that's going to be my first point. Now, in order to do that, I'm going to get everything without a dy dx on one side. So I'm going to subtract 2x and subtract y. So I get x dy dx plus 2y dy dx equals -2x minus y. Now, both of these things have a dy dx, so I can factor it out. I can do, dy dx times x plus 2y equals -2x minus y. And then I'm just going to divide both sides by this crazy mess. X plus 2y, divide by x plus 2y. These cancel out, and I'm left with dy dx equals -2x minus y over x plus 2y. And that's the equation for the slope. And so I've earned my first point. But we want a tangent line at a point. We need a slope at a certain point. So I'm going to plug in 1 and -4. And you'll usually see this written as dy dx. They drew a line just like we did in the last integral problem. And they'll say, okay, x is 1, y is -4. And that just means, hey, we're plugging this stuff in. So -2 times 1 minus -4. 1 plus 2 times -4. And that's your slope. Now, if you wanted to, you could take this whole thing and plug it in to your tangent line equation. And they would take it. If you just put this in brackets and stuck it up there, they would take it. I think that's a little weird. I think often people are going to want to simplify these. So I'll simplify it real quick. What would this be? -2. So it would be 2 divided by 1 plus -7. So I would just say, oh, it's y plus 4, -2 over 7 times x minus 1. And that is my last point on this problem. Okay? And I say, yay, I love math.